Mountains cover a quarter of all land on our planet. That's billions and billions of tons of rock reaching up to the sky. The Himalayas alone have more than 100 mountains taller than any peak in the Americas. These stone giants control the climate, create rivers, and decide where rain will fall. But here's what changes everything you thought you knew. These huge, heavy mountains are floating. Yes, floating like giant rock icebergs on a sea of melted rock far below. And there's more. The same force that creates mountains also causes the most terrible earthquakes and the most violent volcanic eruptions. How can the same forces that give us fresh water and clean air also bring so much destruction? Subscribe to the channel, leave your like and comment what part of the world you're watching from, because now I'm going to tell you everything. What if the ground beneath your feet is not as steady as you think? When you look outside, the ground and land seem strong and solid. You see grass, roads, maybe hills, and think the earth will always look the same. It feels like nothing could move the ground under your house, your town, or your city. But deep below your feet, huge changes are happening all the time. The earth you live on is not just one big, hard shell. Instead, it is made up of many giant pieces. These pieces are called tectonic plates. Tectonic plates are like the giant pieces of a puzzle that fit together and cover the whole earth. They are not just lying flat and simple. Some plates carry the big land areas we call continents. These are places like Africa, South America, and Asia. Other plates hold up the huge oceans between the lands. Every continent and every ocean rests on some part of a tectonic plate. This means that everywhere on Earth, the ground you see is sitting on something much bigger and thicker below. If you could look at the Earth from above, but see all the way through to the bottom, you would see these plates all fitting together, side by side. There are not hundreds of little plates, but just a few big ones and a few smaller ones. Each plate fits tightly next to the others. Where these plates meet, there are long lines or cracks. These lines are called plate boundaries. Some of these boundaries are under the sea, far away from where anyone lives. Some are in the middle of continents or close to the edges where oceans meet the land. The Earth's plates are not all the same size. A few of them are very large and spread out under more than one continent or one ocean at a time. Some plates are so big that they stretch across many thousands of kilometers. Other plates are smaller but still very large. There are also a few even smaller plates in some places. All these plates together cover the surface of the Earth, like a giant jigsaw puzzle with only a few pieces. You cannot see these plates just by digging in the ground with a shovel. If you go outside and dig down, at first you will find dirt, then rocks. This is called the crust. Below the crust is where the tectonic plates are. Each plate is thick and strong, much thicker than the ground we usually see. A plate might be dozens of kilometers thick from top to bottom. Even the thinnest plates are many kilometers thick. These plates are not just sitting quietly. They move, but the movement is very slow. The movement is much slower than what your eyes can see. In 1 year, most plates move only a few centimeters. That is less than the width of your hand. This seems so small that most people would never notice, but over many thousands or millions of years, this small movement changes the whole planet. The slow movement of tectonic plates is not random. The plates do not all go in the same direction. Some plates move toward each other. Some move apart. Others slide past each other. The edges where plates meet are the places where you find a lot of change, like high mountains or deep ocean trenches. These changes are not quick, but they build up over a long time. Why do the plates move at all? The top of the Earth might seem cool and calm, but under the surface, it is very hot. The inside of the Earth has energy and heat. This heat comes from very deep inside and helps push the plates around. The plates float on a part of the Earth that is softer and hotter than the hard crust above it. You can imagine it is like a raft floating on a slow-moving river, but even slower. The movement of tectonic plates is called plate tectonics. This is the process that shapes the way our world looks. Mountains, valleys, ocean floors, and even islands are made and changed by these moving plates. When you see a mountain or a wide, flat plain, you are looking at a place that was shaped by this slow movement. Even the ground beneath your home was once in a different place long ago, before the plates moved it. The space between two plates can stretch, pull apart, or be squashed together. This is possible because the plates do not cover the planet in one single, unbroken piece. They move and change slowly, which is why the map of the world has changed through time. Millions of years ago, the continents were joined together in different ways than they are now. As the plates moved, the continents moved apart or came together. For example, the continents of South America and Africa fit together almost perfectly along one edge. Long ago, they were joined as one piece of land. Over millions of years, the plates moved apart and the Atlantic Ocean grew between the two continents. Other places, like India, have moved long distances over time. India used to be an island far from Asia, but as the plates shifted, it slowly moved north until it hit the big Asian plate and pushed up the land to make the Himalaya mountains. The ground may feel very strong and steady, but you are always sitting on something that is slowly drifting across the earth. You do not notice it because the movement is too small to feel in one day or 1 year. But scientists can measure the plates and see how far they have moved with special tools. They know that even the tallest mountains and the deepest oceans are just parts of these big moving plates. Most people never think about the ground moving, but sometimes it is impossible to ignore. When plates push or slide very quickly, the ground shakes. This is called an earthquake. Earthquakes happen most often along plate boundaries, where the plates are pushing, pulling, or sliding past each other. Some earthquakes are small and only shake a little, but others can be very strong and cause damage. The places in the world where earthquakes happen often are usually the places where two plates are meeting or moving past one another. Some of the biggest and most famous mountains on Earth are found where plates have pressed together for millions of years. For example, the Andes Mountains in South America and the Alps in Europe both formed where two plates met and pushed up the land. There are also high mountains in North America, Africa, and Asia made by plates moving and changing. The process is always going on, but it is easy to forget because it is so slow. If you looked at a map of the Earth from 100 million years ago, the picture would be very different. If you could come back and look 100 million years from now, the map will change again. The plates will keep moving the land and oceans into new shapes. It is important to know that the place you live on was not always there or was not always shaped the same way. The plates might carry your town or city very slowly toward a different place on Earth. This is not something that happens in one person's lifetime, but the whole planet is always changing a little bit each year because of these slow movements. Scientists who study the Earth have found many ways to see how plates move. They use special machines to measure small changes in land and even watch how the oceans spread apart by a very small amount each year. They also use clues in rocks and fossils to know how the land used to look a long time ago. When they put all this information together, it shows a clear picture. The ground moves, the world changes. The changes that happen because of moving plates have shaped all the land we see today. There would be no high mountains, deep ocean trenches, or long chains of islands without tectonic plates and their movements. Even now, the movement never stops. Every continent is slowly moving, every ocean floor is spreading or being pushed under, and mountains are still rising or eroding away. The way the plates cover the planet is also the reason why the ground is sometimes steady and sometimes full of change. In the middle areas of big plates, far away from their edges, the ground is usually very stable. There are fewer earthquakes or volcanoes, but close to the boundaries where plates meet and move, the ground can shake or rise. That is where you find the biggest changes in the land. People have lived on Earth for only a short time compared to how long the plates have been moving. But even in this short time, people noticed hills, mountains, and valleys, and sometimes wondered how they were made. Now, with science, we know the answer is deep inside the Earth's crust, in the slow but powerful movement of tectonic plates. Next time you look at a mountain or cross a plain, remember that it was not always there. Every piece of land is part of a plate that moved from another place or is still moving right now. The Earth is always changing, quietly and slowly, under your feet. The story of tectonic plates is the hidden story that explains why our world looks as it does, with all the mountains, valleys, and plains you see today. The ground may feel strong and fixed, but it is always part of something much bigger and always moving. This movement will shape new mountains, new oceans, and new landscapes for millions of years to come. So, even though the Earth looks peaceful, it is always full of power and change right under your feet. Beneath your feet, there is much more than just the ground you see. The land and seas might look simple from above, but deep inside, the Earth is built from several different layers. Each layer is important in its own way. These layers help explain how the ground can move so slowly and shape everything you see on the planet. The journey to understand mountains, earthquakes, and the movement of the plates begins by exploring what lies below the surface. The outermost layer is called the crust. This is the part of the planet where people, animals, and plants live. You walk on the crust each day. The crust can be thick in some places, especially under big mountains, and a little thinner under the oceans. It is made up of strong rock that has cooled off from when the Earth was much younger. The crust might seem very deep, but compared to the rest of the planet, it is thin. If you could dig straight down, you would find that the crust stretches for only a few dozen kilometers. This is not a lot, since the whole Earth is over 12,000 kilometers in diameter. Right below the crust is a bigger layer called the mantle. The mantle is much thicker than the crust. In many places, it is more than 2,000 kilometers from top to bottom. The mantle is not hard like the crust. The rocks in the mantle are very hot and can move, but they do not move quickly. Instead, they flow very slowly. The rocks here are soft enough to move a little bit over time, but still strong and heavy. The mantle is always under pressure because it carries the weight of the crust and everything above it. Below the mantle, deeper inside the planet, is the core. There are two parts to the core. The outer part of the core is made of very hot, melted metals, mostly iron and nickel. The inner core is even more special. Even though it is just as hot, it is squeezed so tightly by all the weight above that it has become solid like a heavy ball at the very center of the Earth. The core is the hottest part of the planet. The heat from the core is what gives energy to all the layers above it. When you look at a slice of the Earth from the surface to the center, you see four main parts. First the crust, then the upper mantle, the lower mantle, and finally the core. Each part is different in temperature, thickness, and the kinds of materials inside. The differences between these layers are what let the tectonic plates move and give the Earth its constantly changing shape. The crust is made up of different kinds of rock and minerals. Under the oceans, the crust is usually darker and made from a kind of rock called basalt. Under the continents, the crust is often made of lighter rocks like granite. These rocks can be broken, bent, and shaped as the tectonic plates move around on top of the mantle. Every part of the ground you know, from the highest mountains to the deepest seas, is part of the crust. In some places, the crust breaks and forms cracks or gaps. These breaks are called faults. Faults are found near where plates meet. At a fault, the pieces of the crust are pushed, pulled, or rubbed against each other. The movement along faults is one reason why earthquakes happen. Most faults are not visible on the surface, but sometimes you can see them as long lines, steps, or cliffs in the landscape. Moving deeper, the mantle is much warmer than the crust. The rocks of the mantle are made hot by the core below them. The heat causes some parts of the mantle to rise while cooler parts sink. This is a slow process called convection. These movements in the mantle are not fast. A single part of the mantle might take millions of years to go up or down even a short distance. But every bit of movement in the mantle helps push and pull the tectonic plates above it. The boundary between the crust and mantle is called the Mohorovičić discontinuity, but most people just call it the moho. The moho is not a hard barrier, but a zone where the rock changes from the kind found in the crust to the hotter, different rock found in the mantle. Scientists learn about the moho by studying earthquakes. When the ground shakes, waves travel through these layers, and the way the waves move tells scientists what is down there. The core sits deep under the mantle and is split into the outer core and inner core. The outer core's metal is always melted because it is so hot. In the very center, the inner core, the pressure is so great, the metals become solid. The temperature at the core is much higher than anywhere else inside the Earth. This heat keeps the mantle moving. The core also helps the Earth have a magnetic field, which is important for life on the surface. The heat from the center of the Earth is always rising upwards. As the heat reaches the lower mantle, it causes the rock to rise in slow currents. When the hot rock goes up, cooler rock from above sinks to take its place. This up and down movement is one of the most important forces that moves tectonic plates. The plates above the mantle float on it and are moved along by this slow, steady churning. In some places, plumes of hot mantle rise faster and can melt holes in the crust. This happens in places like Hawaii, where islands are made from volcanic eruptions. The movement between these layers is not something you can see, but it is always happening. Sometimes, when the mantle moves in a new way, it can cause big changes above. Volcanoes can form, earthquakes can shake the ground, and even mountains can grow higher. All of these things depend on how the crust, mantle, and core are working together. Scientists have learned about the layers inside Earth by using special tools and by studying how waves from earthquakes travel. They cannot dig all the way to the mantle or core, so they have to look for clues. It took many years to learn that the mantle is hot, soft, and moving, and that the core is made of iron and nickel. When scientists listen to the sounds the Earth makes during big earthquakes, it tells them where each layer begins and ends. For example, some waves from earthquakes can travel only through solids, not liquids. By seeing which waves arrive and which do not, scientists map the inside of the planet. People who study the Earth are called geologists. Geologists have found evidence of the crust, mantle, and core by looking at rocks pushed to the surface, studying volcanoes, and measuring the Earth's gravity and magnetism. In some volcanoes, rock from the mantle is brought up to the surface, and these rocks are different from the rocks in the crust. Each time a new piece of information is found, scientists learn more about the Earth's hidden layers. The rocks in the mantle are heavy and can flow because of heat. Over millions of years, the weight and heat change how the mantle works. When the mantle pushes hard enough against the crust, it causes the tectonic plates to move. The slow, churning movements of the mantle are always moving the plates, even if only by a small amount each year. The heat in the core is left over from when Earth was first formed. When the planet was young, everything melted because it was so hot. As the Earth cooled, the crust formed on top, but the inside stayed very warm. The core is still hot, and this heat will keep the mantle moving for many millions of years. The heat also causes the metal in the core to move in circles, creating the Earth's magnetic field, which helps protect life from harmful rays from space. The different layers change the way the whole planet works. The crust is always moving on the slowly flowing mantle. The mantle keeps changing shape as heat rises and cools. The core keeps making heat and a magnetic field. If the layers stopped working together, mountains would stop growing, Earth's surface would not change, and life would be different. The surface would become flat in time, because mountains would wear down and no new ones would form. Every mountain, island, and even the ocean floor began as part of this moving system of layers. Sometimes, new crust forms when the plates pull apart and melted rock rises from the mantle. Sometimes, old crust sinks back into the mantle and melts. These processes ensure that the surface is always new in some places and older in others. The differences in the crust above the oceans and above continents matter as well. Ocean crust is thinner, heavier, and younger. It often breaks apart and gets pushed under other plates. Continental crust is thicker, lighter, and older. Because of these differences, volcanoes and earthquakes happen in different places and in different ways. Sometimes the mantle pushes against the crust more strongly. When this happens, the crust can buckle or tear. Where the crust is weak, magma can rise up from the mantle and break through. This creates new islands in the oceans, or sometimes leads to eruptions that form new land on continents. Hot spots, like those under Hawaii and Iceland, are areas where the mantle is especially active. The boundary between the crust and mantle is not always at the same depth. Under mountains, the crust can reach over 70 kilometers deep, but under oceans, the crust may be less than 10 kilometers thick. The differences in depth help explain why some places are flat and others are high. The mantle is very important because all the movement of the plates starts there. The layer flows, twists, and churns, but does so extremely slowly. Over millions of years, this movement sends continents drifting, breaks apart ocean floors, and creates new landscapes across the world. Below the mantle, the outer core is always spinning. This motion helps protect the planet and guides the direction of the magnetic field. Without the motion of the outer core, compasses would not work, and the Earth would lose some of its protection from space. The inner core has its own special qualities. Even though it is hotter than anywhere else on the planet, the pressure from the weight above makes it hard instead of soft. The inner core is always growing a little bit as the Earth cools, but it will take millions or billions of years before much changes there. These layers, crust, mantle, and core, each work together as a team. Their different properties and temperatures keep the movement going. Without the heat from the core and the softness of the mantle, tectonic plates would not move. Without this movement, mountains could not be pushed up, volcanoes would not erupt, and the planet would not look anything like it does today. Even though the journey to the core is impossible for people, every earthquake, volcano, and new piece of land shows that the inside of the Earth is always changing the outside. These changes may be slow, but they are very powerful. So, when you step onto the ground, think about everything below. There are rocks, heat, melted metals, and deep, slow movements all the way to the center. The result of all these layers working together is a planet that is alive with change, even if you cannot see it. Each movement, every ripple in the mantle, helps move the plates and shape the land above, making mountains, valleys, and oceans. The land we see is only the very top of a deep and active planet. Everything happening below continues to drive the movement above, and this is how the face of our world keeps being shaped and changed, one slow moment at a time. Every part of the Earth's deep structure plays a role in what happens at the surface, but it is the movement itself that holds everything together. Heat from the core spreads into the mantle and creates a slow movement of rock far beneath the ground. This movement is what pushes and pulls the tectonic plates above. These plates may seem still, but they are always slowly moving because of the heat rising from deep inside the planet. The energy that comes from the core is not like the energy from the sun. It is a different kind of energy that comes from inside the planet. It is made by old heat left from when Earth was formed, and also by energy released from tiny particles inside the rocks of the mantle and core. These tiny particles are always breaking down and letting out more heat. Because of this, the inside of the Earth stays hot, even after billions of years since the Earth began. This heat does not stay in one place. It has to move upward, and as it does, it causes the rocks in the mantle to flow very slowly. This flow is called convection. The heat rises, and as it reaches the cooler parts near the top of the mantle, it spreads out and loses its energy. Then cooler rock goes down again to take its place. The whole process makes the mantle move in a slow, rolling motion, like a long, slow wave. The motion in the mantle is slow. A single piece of the mantle might take millions of years to travel from the bottom toward the top, across a wide distance, and then back down again. But even though it moves slowly, it is strong enough to move entire plates above it. These plates are very thick and wide, but the constant movement below makes them drift across the top of the mantle. Even a movement of a few centimeters each year, when added up over millions of years, can completely change the face of the planet. Tectonic plates can move in a few different ways, and each type of motion causes special shapes at the surface. Sometimes two plates move away from each other. Sometimes two plates move towards each other. Sometimes two plates slide past each other, moving sideways. Each way of moving changes the ground above in a different way. When two plates move away from each other, this is called divergence. This usually happens in the middle of oceans, where the ocean floor splits apart. As the plates move away from each other, hot rock from the mantle rises up to fill the space. The hot rock cools and becomes new crust. This is how new ocean floor is made. The plates keep moving apart, and more hot rock fills the gap, building up long underwater mountains called mid-ocean ridges. These ridges can be thousands of kilometers long. The most famous one is the Mid-Atlantic Ridge, which runs all the way down the middle of the Atlantic Ocean from the north to the south. New crust is always being made here, and the ocean floor slowly spreads wider every year. When two plates move towards each other, this is called convergence. There are different things that can happen when plates meet. If they are both ocean plates, one can slide under the other and be pushed back down into the mantle. If one plate is continental and the other is oceanic, the heavier ocean plate is usually the one that goes down. If both plates are made of continental crust, they can push up against each other and make the land fold and crumple. This is how some of the world's biggest mountain ranges are formed. When one plate goes under another plate, the place where this happens is called a subduction zone. The plate that goes down will slowly melt as it gets deeper, and this can lead to the creation of volcanoes above on the surface. These areas are often very active, with many mountains, volcanoes, and sometimes earthquakes. The third way plates can move is by sliding past each other. This is called a transform boundary. The plates move sideways, rubbing along their edges. The movement is not always smooth. Sometimes the plates get stuck, and when they finally slip, the ground shakes. People feel this as an earthquake. There are both small and large transform boundaries in the world, but the most famous is the San Andreas Fault in California, which can produce strong earthquakes. All of these movements are powered by the slow but never-ending flow of the mantle beneath the plates. The energy from the hot core is what starts all of it. The mantle flows because it is heated from below and cooled from above. As long as the inside of the Earth stays hot, the mantle will keep moving and the plates will keep drifting. When the plates move, the whole surface of the planet is affected over long times. Continents move, oceans open and close. Mountains, volcanoes, and earthquakes are all signs of the energy that comes from inside the Earth. Even though these movements are slow, they are steady. If you measured the movement of a plate each year, you might find it only moved a few centimeters. But if you measured it over tens of millions of years, it could move thousands of kilometers. Scientists have studied how fast plates move. Using special instruments, they can measure the distances between continents or even between mountains every year. The movement is always there, even if it is hard to notice without instruments. The fastest moving plates can travel more than 10 centimeters each year. The slowest move only a few centimeters each year. Over a very long time, these small movements add up to create very big changes. Because the plates move, the shape of the continents keeps changing. Millions of years ago, the world's continents looked very different from what you see today. There were times when all the land was joined together in one huge continent called Pangaea. Over many millions of years, the plates moved, the land broke apart, and the pieces drifted to different places. Now, the continents are spread out across the globe, but even now, they are still moving. Some are moving closer together, while others are drifting apart. As the plates move, they also change the shape of the oceans. When the plates pull apart, new ocean floor forms between them, making the oceans wider. When one plate goes under another, deep ocean trenches are formed. These are some of the deepest places on Earth. The Mariana Trench in the western Pacific Ocean is the deepest trench in the world. It was formed by one plate sliding under another over a very long time. Earthquakes happen most often at the edges of plates. This is where the plates scrape, push, or pull against each other. The stress builds up, and when the plates suddenly move, the ground shakes. Some earthquakes are small and only last a few seconds. Others can be very strong and last a bit longer, sometimes causing damage to buildings and roads. The strength of an earthquake depends on how much stress has built up before the plates move. Volcanoes are also found near the edges of plates, especially where one plate moves under another. As the plate sinks, it melts, and the hot, liquid rock rises toward the surface. When it breaks through, it can create a volcano. Some volcanoes are active and erupt often. Others may be quiet for many years and then suddenly become active again. Some plates carry large continents. Others are under the oceans. The continents are made of lighter rock. That is why they float a little higher on the mantle. Ocean plates are made of heavier rock, and so they sit lower under the oceans. When two continental plates meet, neither one sinks easily. Instead, the land crumples and pushes up high, creating mountains like the Himalayas, which continue to grow each year as the plates keep moving. When plates move apart under the oceans, magma, which is hot, melted rock from the mantle, rises up to fill the space. As the magma cools, it becomes solid rock, adding a new layer to the ocean floor. This is a never-ending process, and it is why the ocean floors are much younger than the continents. The oldest ocean floors are usually not more than 200 million years old, while some rocks on the continents are over 3 billion years old. In places where plates slide past each other, you often find long cracks in the ground. These are called faults. Faults make the ground move in sudden jumps. This is why earthquakes are so common in places like California and Turkey, where two plates meet and slide against each other all the time. There are not only big plates on the planet, there are also smaller plates that move around between the larger ones. these pieces can bend, break, or even get squeezed between bigger plates. The places where all these plates meet are usually very busy, with many earthquakes and volcanoes. Sometimes a plate can get stuck. Instead of moving smoothly, it stops, and the pressure builds up over many years. When the plate finally moves again, all that energy gets released at once. This is what causes some of the world's biggest earthquakes. The movement of plates changes the face of the world slowly, but always. Every year the land shifts a little. Every century, mountain ranges might grow a tiny bit taller. Every few million years, whole continents may move to new positions. Because the surface of the earth is always changing, plants and animals must also change and adapt. Many different kinds of life have grown and spread across the world, only to be moved or separated as the continents drifted apart or came together. Large animals once walked across lands that are now separated by oceans. Fossils show that this has happened many times throughout Earth's history. All these changes are not just something from the past. The world is still changing. Scientists use satellites to watch the plates move and see new islands form when volcanoes erupt. People who live on plate boundaries often feel small earthquakes or see smoke from volcanoes. These are signs that the plates are always in motion. Sometimes big events can happen quickly. An earthquake can shake the ground in just a few seconds. A volcano can erupt and form a new hill in just a day. But most of the time, the changes are very slow. Mountains are made, rivers shift their courses, new land forms at the edges of the oceans, and old land is pushed back down into the mantle. The constant movement of the plates makes the planet unique. Other planets in our solar system have mountains and volcanoes, but they do not have tectonic plates like Earth. That is why Earth has such high mountains, deep ocean trenches, and so much variety in the land. The same force that moves the plates helps shape the weather too. As mountains rise, they can block rain, change the wind, and even affect where rivers flow. The shape of the land, made by the moving plates, helps decide what grows in each part of the world, where people can live and where animals roam. In every moment, the ground under your feet is part of a plate that is slowly moving. You do not feel it, but over millions of years, these small movements will change where the land is, what the land looks like, and what life can survive there. The power that moves the plates comes from deep inside the planet, from the core and from the mantle. The movement of tectonic plates shapes everything about the Earth. Mountains, valleys, plains, volcanoes, and ocean basins are all created and changed by this force. The energy never stops. It comes from the hottest, deepest places inside the planet, travels through the soft, moving mantle, and pushes or pulls the plates above. Over long times, this will create new mountains, build new oceans, and bring new changes to the planet's surface again and again. The slow movement of the tectonic plates is what builds the tallest and most beautiful mountains on Earth. Over millions of years, the way the plates crash into each other or press together shapes the ground in ways that can rise high into the sky. These forces are slow, but their results are strong and last for a very long time. Every time two tectonic plates move toward each other, a powerful process begins. The plates are made of hard rock and are very wide and heavy. When they meet, they do not just stop or slide over each other easily. They keep pushing against one another because they are being moved by the mantle below. This pushing does not make the plates move up or down right away. Instead, the rock between them is squeezed and begins to bend, wrinkle, and fold. Over many thousands of years, and then over millions of years, all this bending and folding adds up. The land slowly crumples and begins to move upward in some places. The more the plates press together, the more the ground is pushed up. This is how many of the world's largest mountain ranges have formed. There are many places on Earth where you can see this process. The Himalaya Mountains are one of the clearest examples. Long ago, the plate that carries India began moving northwards toward the larger Eurasian plate. When India collided with Eurasia, the two continent plates were pressed tightly together. The rocks between them folded and rose higher and higher. This formed the Himalayas and made them the highest mountains on the planet, with peaks that are thousands of meters high. The collision is not finished. Even today, the Himalayas are still rising each year, even if only a few millimeters or centimeters at a time. The Alps in Europe, the Andes in South America, and the Rocky Mountains in North America were all made in this way, when two plates pressed together and the land in between was pushed up and crumpled. Every high fold and sharp peak in these ranges shows how strong the force of plate movement can be over millions of years. These mountain ranges take a very long time to form. It is not something that can happen in one lifetime or even many lifetimes. This process does not always start in the same way. Sometimes both plates are continents. Sometimes one plate may be heavier and made of ocean rock while the other is a continent. But when two continental plates come together, neither one is heavy enough to simply sink down into the mantle beneath. Both blocks of rock push against each other, and the only way they can move is by folding and piling up higher and higher. The ground does not break in smooth or perfect ways when plates smash together. The land can break, twist, and jumble. Big cracks called faults can open up. Rocks are carried upward, and sometimes the oldest rocks from deep inside the earth are pushed on top of younger rocks by this folding. This is why, in some tall mountains, you can find rocks that are much older than the ground around them. When you stand at the base of a giant mountain or look across a range, you are seeing the result of millions of years of plate collision. It can be hard to imagine, but every meter of height, every valley and peak comes from pressure slowly building up as the plates move together. It is the quiet force of the earth changing its own shape. The speed at which mountains rise depends on how fast the plates are moving and how much force is pushing them together. In some places, mountains can rise several millimeters or even a centimeter in 1 year. That does not sound like much, but over 1,000 years it adds up to many meters. Over 1,000,000 years, the mountains can grow very high. The process is so slow that you will not see it happening with your own eyes. But scientists can measure the changes with special tools, and the numbers show that the ground keeps moving. Sometimes, as the mountains rise, the rocks crack and break apart. Water from rain and melting snow finds its way into these cracks. The water can freeze and push the rocks apart even more. As a result, the tops of mountains can be very broken and jagged. At the same time, the land at the base of the mountains may still be rising slowly as new force comes from deep inside the earth. This does not happen only in big mountain ranges. Even small hills and small mountain chains can form in places where plates press together. Sometimes the land bends upward less, so only a row of gentle hills forms. Other times the process is stronger and sharp, high mountains grow. The effect of mountain building is not just seen in the mountains themselves. Far away from the main collision, the land can bend or sink down. Giant valleys or low areas called basins may form near mountain ranges. This is because all the force of pushing and folding does not just act in one small place. It spreads out over hundreds or thousands of kilometers, and the rocks respond in many ways. As the ground rises, rivers start to cut down through the new land. Glaciers can move across the rising land and scrape it flat or carve out deep valleys. Over millions of years, the mountains get higher, but the wind, water, and ice always try to wear them down. The balance between up and down, between pushing up the land and breaking it down, is always ongoing. The highest mountains are in places where the pushing force is still strong and not much has been worn away. Not every place where plates meet forms high mountains. Sometimes, when an ocean plate comes against a continent, the heavier ocean plate slides under the lighter continent. This also can build mountains, especially near the edge of the continent, but the process is a little different and leads to other kinds of events, like volcanoes. However, when two big continents push together, it is the folding and crumpling that builds some of the broadest and tallest mountains on Earth. The Himalayas show clearly how this works. Over the last 50 million years, the Indian plate has moved north and crashed into Eurasia. The force is so great that the mountains are still getting higher today. There are also earthquakes in this area as the pressure builds up and is suddenly released. The ground here is never quiet, always changing as the plates press against each other. Places like the Rocky Mountains and the Alps formed when smaller plates or blocks of land crashed into bigger plates. When this happens, the pieces of land are caught and pushed up, making new mountains. In some cases, the old pieces of crust are pushed far onto a continent, creating complicated patterns of old and new rock. Sometimes, old pieces from the ocean floor are even found on top of high mountain peaks, showing just how complex the movement can be. Besides the building up of the land, other things change when mountains form. The climate and weather can change on either side of a new mountain. As the land rises higher, the temperature becomes colder and the air becomes thinner. Rain may fall on one side of the range more than the other, leaving one side green and the other dry. Rivers start to flow in new directions, finding the fastest way down from the high mountains. The valleys between the mountains collect water and soil, helping plants to grow. There are many signs of mountain building in the world. Scientists look for folded rocks, fault lines, and old seashells on mountain tops to understand how the land has risen. Sometimes fossils from animals that lived in the sea are found high on mountains. This is proof that the land was once flat and underwater, but over millions of years was pushed high by the movement of the plates. Mountains made by folding and crumpling usually appear in long lines or chains. These are called mountain ranges. Sometimes a range goes on for thousands of kilometers. The Andes, for example, stretch down almost the entire length of South America. Each mountain range has its own history, depending on how the plates moved in that place and what kinds of rocks were pushed up. Folded mountains are not the only result of this process. In some places, giant blocks of land are pushed up faster than the land around them. This can make steep cliffs called fault block mountains. In other places, the land breaks into many smaller pieces and pushes up a whole region, creating smaller mountain ranges or plateaus. All these mountain building processes are happening somewhere right now, although they are usually too slow to see. There are mountains rising in Asia, in South America, and in many other places. Where the plates meet and the movement has not stopped, mountains continue to rise a little each year. Earthquakes often happen in mountain ranges that are still being built. The pressure from the plates can get stuck in the rocks until there is too much stress. When the stress is suddenly released, the ground jumps and the land can move several meters in an instant. These earthquakes change the shape of the land and sometimes make the mountains higher or lower, or move them slightly to the side. The building of mountains is only part of the story. While the process can push land higher for millions of years, the forces of rain, wind, ice, and rivers are always working to tear mountains down. Sharp peaks can become rounded. Tall mountains can be worn down to hills. The story of mountain building is also a story of balance between creation and destruction. Some mountains are made of different types of rock layered on top of each other. The folding process can twist these layers into waves, loops, and even upside-down shapes. The different rocks can erode at different rates, which makes the shapes of the mountains very interesting to see. All of the world's highest places, the peaks, the sharp ridges, the wide valleys, owe their form to the slow but powerful force of two plates pressing together. It is the quiet work of the planet, happening during the day and night in every season over millions of years. The land will keep being pushed up as long as the plates keep moving with their slow, unstoppable force. This pushing, folding, and rising of land is one of the strongest ways that the inside of the planet changes what happens on the outside. It is not easy to stop mountains from forming if the force behind them is great enough. Even after a range rises, it can remain high for millions of years before the forces finally slow and the mountains start to wear away more quickly than they grow. Every cliff, every steep slope, every valley between peaks tells the slow story of plates meeting in silence day after day. Sometimes the changes are very small, just a few millimeters in 1 year. Other times the plates move a little faster, or an earthquake can jolt the land much more quickly. Over long times, these events create landscapes that become some of the most important and beautiful places on Earth. In many countries, people live in the shadow of mountains that were made by the crushing and folding of the crust. Acting as barriers, homes, and water sources, these mountains are a direct result of the powerful movements deep inside the planet. The forces that make mountains are always working, making sure that the Earth's surface is never the same for very long. Every mountain range is proof of the strength that comes from the slow movements of huge plates at the bottom of the crust. The story of mountain building is the story of great patience and strength. Step by step, year by year, the plates bring up the land, shape the valleys, and leave behind marks of these long-ago collisions. The world we see is shaped in large part by these vast, silent movements under our feet, giving rise to the peaks and ridges that define our planet's face. When plates meet, the land can push upward to form mountain ranges. This is not the only way mountains can be made. There is another process that shapes the land in powerful and sometimes dramatic ways. This involves one plate moving underneath another in a process called subduction. Subduction zones are some of the busiest and most dangerous places on the planet. Here, both mountains and volcanoes are made through special processes deep inside the Earth. A subduction zone is a place where one tectonic plate slides beneath another plate. Most often, the plate that sinks is made of ocean crust because it is denser and heavier than the continental crust. As the heavier plate is forced below, it goes deeper into the Earth's mantle. The mantle is hot, and as the plate moves down, it gets hotter and starts to melt. The melted part of the plate mixes with the rock in the mantle, and this mixture can start to rise again. The plate that remains on top does not just sit still. It gets pushed and lifted by the force of the plate going underneath. This can create a whole chain of mountains along the edge of a continent. These mountains may not always be as tall as the ones made when two continents push together, but they are often very long. The Andes Mountains along the west side of South America were created in this way and continue to rise today. As the plate beneath melts, the hot, melted rock, which is called magma, is lighter than the rocks around it. The magma begins to move upwards because it is less heavy. Sometimes the magma reaches all the way up to the surface of the Earth. When this happens, it comes out as lava during a volcanic eruption. The lava cools down when it touches air or water, and it forms new rock. Each eruption adds more layers on top of the old ones, and gradually a mountain is built. When a mountain is made from many eruptions, it is called a volcanic mountain. Volcanic mountains can grow quickly when there are many eruptions. Some volcanoes shoot out huge amounts of lava, ash, and rocks in a single day. Others erupt more slowly over a long time. Sometimes many years pass between eruptions. The shape, size, and steepness of a volcanic mountain depend on the type of lava, the amount of ash, and how often the volcano erupts. Volcanoes often form a line or a chain near the edge of a continent or an ocean. This is because these are the places where subduction zones are found. Around the Pacific Ocean, there are many volcanoes closely spaced together. This is sometimes called the Ring of Fire because so many eruptions and earthquakes happen along its edge. Countries like Japan, Indonesia, Chile, and the United States have many volcanoes that come from subduction. The ground near volcanoes can change quickly. When a volcano erupts, it can add new land in just a few hours or days. Sometimes volcanic islands rise out of the ocean almost overnight. Other times, a mountain that has taken thousands of years to grow might suddenly lose its top if a large eruption blows it away. The ground can be covered with ash, lava flows, or mudslides. Not every subduction zone creates the same kind of mountains. Sometimes the ocean floor has hills, volcanoes, or even small islands on it. When these get pushed under a continent, they can stick, pile up, or get squeezed into the edge of the continent. This adds even more rock and material to the mountains above. Layers and pieces of seafloor can end up high above sea level. Over millions of years, whole parts of ancient oceans may become part of a tall mountain chain on land. Volcanic mountains can also form in the middle of a plate in a special way. In some places, hot rock from deep inside the mantle rises in a column called a hotspot. The rock melts as it rises, and when it reaches the surface, it forms a volcano. Over time, as the tectonic plate moves over the hotspot, a line of volcanoes can appear. The Hawaiian Islands are an example of this. The youngest island sits over the hotspot and is still growing from fresh lava, while the older islands are quiet because they have moved away from the source of the melting. Back at the plate boundaries, the process of subduction does not just make mountains and volcanoes. It is also linked to earthquakes. The plate that is being forced down does not slide smoothly. Sometimes it gets stuck deep underground. As it tries to keep moving, pressure builds up. When the pressure is finally released, the plate jerks forward, sending waves of energy through the ground. This is an earthquake. Subduction zones are some of the most earthquake-prone places in the world. Because of all the melting and movement, subduction zones create many different types of rocks. When magma cools below ground, it forms hard, strong rocks called igneous rocks. The heat, pressure, and mixing of old sea floor with melted mantle can make new rocks that are different from those found in the high-folded mountains. Subduction can also help form deep ocean trenches. As the plate is pulled under, it leaves a big, deep dip in the ocean floor, not far from the continent's edge. The Mariana Trench, near the island of Guam, is the deepest trench in the world, reaching almost 11,000 meters below sea level. This trench marks the place where one plate slides beneath another. There are special patterns to the way mountains and volcanoes are arranged around subduction zones. Often, a deep ocean trench is found first. Then, a line of volcanic mountains sits behind the trench on the edge of the continent. Beyond the mountains, wide valleys and plains can form as the land is stretched and shaped. Life near volcanic mountains and subduction zones can be challenging but also very rich. The soil formed from volcanic ash is often dark and full of nutrients. Plants, crops, and forests grow well there. Some of the world's biggest cities were built near volcanoes because the land is good for farming. At the same time, the people who live near these places must always be ready for volcanoes and earthquakes. When a volcanic mountain is formed, its shape can be very different from a typical folded mountain range. Some volcanoes are shaped like cones with sides that are steep and pointed. Others are wider with gentle slopes depending on the type of lava that flows out. Over time, wind, rain, and ice will wear down the volcano, breaking rock and turning it into soil. Volcanoes can have many shapes and sizes. Some are small hills that might erupt only once and never again. Others can grow to be thousands of meters tall and active for millions of years. The world's highest active volcanoes are found in the Andes Mountains of South America, where subduction is taking place. Subduction can also make chains of volcanoes that rise out of the ocean. When this happens, islands are formed one by one. Many island nations in the Pacific and Indian Oceans are made up of volcanic islands born from subduction. Old volcanoes may sink below the waves as they are worn away, while new ones rise near the plate boundary or hotspot. Beneath each volcano, there are chambers where the magma gathers before it erupts. These chambers fill slowly as melted rock rises from the mantle. Sometimes gas builds up in the magma and the pressure rises. When the pressure is too great, the volcano can erupt suddenly. Some eruptions are quiet and just send out a flowing river of lava. Others are violent, exploding with great force, sending ash and rocks high into the sky. Volcanic eruptions are part of a natural cycle. Eruptions bring nutrients to the surface, change the shape of the land, and help new plants to grow. Over many years, old lava flows are covered with soil and become new places for forests and farms. Even though eruptions can be dangerous, they are also essential in the slow changes that make the Earth rich with life. Mountain building at subduction zones happens together with the making of volcanoes. The edge of a continent where subduction happens is often where great chains of mountains and rows of volcanoes are found side by side. The land is pushed up by the plate movements, and at the same time, new rock is added by lava from eruptions. Sometimes, the ocean floor has chains of old volcanoes or thick piles of rock that are pushed up onto the continent as the plate moves. These pieces are called terranes. Over millions of years, the stacking and sticking of these terranes create a mix of rocks that tell the story of ancient oceans and volcanoes now high in the mountains. Subduction zones are not just places of destruction. They also create new land and bring important materials to the surface of the Earth. Many of the world's richest mineral deposits, like copper, silver, and gold, are found near volcanic mountains formed by subduction. Hot water and steam moving through cracks in the rocks pick up metals from deep inside the Earth and leave them behind as ores when the water cools. The shape of the land in a subduction zone is always changing. Some volcanoes get higher after each eruption, while others get lower after a great explosion collapses the top. Old volcanoes can become quiet for thousands of years, and the forces of wind, water, and ice will slowly break them down. New volcanoes may rise if the conditions in the mantle and crust are right. Mountains made by subduction and volcanoes can also create natural lakes. Sometimes, when a volcano erupts, the top part collapses and makes a deep hole called a caldera. Water can fill these holes over time, creating beautiful lakes surrounded by high mountains or pointed peaks. Some famous lakes around the world were made this way. Because subduction is a slow process, the land changes over very long times. Ocean basins open and close, new mountain ranges and volcanoes rise up, and old ones sink down or wear away. Even when one subduction zone disappears, another can begin somewhere else as plates keep moving. Some of the world's most important mountains, like the Cascades in North America, the Japanese Alps in Asia, and the Southern Alps in New Zealand, are all made this way. All these ranges are shaped by the slow push and pull where one plate dives beneath another and the forces of hot, melted rock reach up to the surface. While the process is slow, sometimes big changes come quickly. A very large eruption or earthquake can change the shape of the land in just a few hours. Lava flows can cover forests and fields, while huge clouds of ash can block the sun and change the weather for days or weeks. Scientists are always watching volcanoes and subduction zones. They use special machines to measure shaking in the ground, temperature in the rocks, and even small changes in the tilt and rise of a volcano's slopes. This helps predict when eruptions or earthquakes may happen, but it is never possible to know exactly when the ground will move. People living near subduction zones learn to prepare for earthquakes and eruptions and rebuild when the land changes. Subduction zones and volcanic mountains are powerful signs of the planet's constant change. The land does not stay the same for long. Plates keep moving, land is pushed together, melted, and brought back up. The story of volcanic mountains and subduction is the story of the Earth renewing its surface. Each new mountain or volcano is a reminder of the deep forces at work under your feet, building, destroying, and shaping the land for many millions of years to come. Mountains do not stay the same after they are formed. The forces that create mountains are very strong, but there are other forces that are always working to change them. Once a mountain rises, it does not remain sharp and tall forever. Year after year, rain falls, snow gathers, winds blow, and rivers cut through the rocks. These simple actions slowly change the shape and height of every mountain on Earth. When a mountain is new, the peaks can be steep and high. The sides may be rough or jagged. Over time, different parts of nature begin to wear these sharp places down. This process is called erosion. Erosion happens everywhere, on mountaintops, on grassy hills, by the sides of streams, and even on flat land. Every time wind moves dust, every time water runs over rocks, some tiny part of the earth is carried away. One of the strongest causes of erosion on mountains is rain. When clouds form over the peaks, rain falls and soaks the rocks and soil. If it rains often and heavily, as it does in some mountain regions, the land washes away faster. Little by little, rainwater seeps into the cracks, making them wider. If the temperature drops and the water freezes, the ice can break rocks apart. This is because ice takes up more space than liquid water. When it expands, it pushes against the sides of each crack. After many cycles of freezing and melting, the rocks start to break into smaller pieces and slowly move down the slopes. Snow also changes mountains over long periods. In cold places, snow falls and builds up on the peaks and slopes. As it piles up, the snow presses down on itself, turning into ice. When there is enough ice, it begins to flow slowly downhill. This moving ice is called a glacier. A glacier acts like a slow river of ice, carrying small rocks and sand with it as it moves. Over thousands of years, glaciers carve deep valleys and shape the mountain sides. The rocks at the bottom of the glacier scrape against the land, making the surface flat or marking it with long lines. When warm weather returns, the ice melts and water moves more loose stones down the slopes. Wind is another quiet force, but over many years its work adds up. At high altitudes where trees do not grow well and the air is always moving, wind can blow loose soil and sand off the slopes. The wind carries these tiny pieces to new places, dropping them far away. This can flatten sharp points and carry dust from one side of a mountain to another. Rivers and streams are some of the greatest shapers of mountains. As rain and melting snow run downhill, the water gathers into channels. These streams cut into the sides of the mountain and carry away pieces of rock. Over time, a tiny stream can become a wide, deep valley. Fast-moving water can pick up large stones and push them along. In the spring, when a lot of snow melts, rivers can become very strong for a short time and move even larger rocks. Gravity is always pulling rocks and soil down from higher places. Any time a piece of rock breaks off, gravity brings it down to the lower slopes or valleys. Big blocks can fall at once, causing rock slides. Smaller pieces move slowly, but with rain, wind, and snow, everything is pulled lower over long periods. Sometimes, after heavy rains, whole slopes of soil slip down at one time in what is called a landslide. Erosion is not the only thing happening to mountains. Some mountains are still rising as the plates underneath continue to push or collide. As one side of the balance, erosion wears mountains down. On the other side, tectonic forces may continue to push them up. In some places, the rate the mountain rises is almost the same as the rate it is worn down. In other places, erosion wins, and the mountain slowly becomes a hill. Over millions of years, tall, steep peaks can change into more gentle hills. The loose rock and soil from these worn peaks move down to lower ground, collecting in wide valleys. Rivers carry some of this material much farther away, leaving new soil on fields or creating deltas at the end of large rivers. As mountains erode, every part of them changes. The type of rock a mountain is made of decides how quickly it wears down. Hard rocks like granite stay tall and rough for a longer time, while softer rocks like sandstone or shale can wear away much faster. Sometimes a range that was very high millions of years ago now seems only like low hills, with bits of hard rock sticking out above the soft land. The valleys and plains beneath mountains are made from materials carried down by erosion. This soil is often rich and good for growing plants because it is made from many different types of rock ground into small pieces. Forests can grow thick in these soils, and animals find food and water in the valleys and fields below. The shape of each mountain and valley tells the story of the forces that built and then wore down the land. A sharp peak may show that the mountain is still young or rising quickly. A rounded hill or a wide open valley is often much older, shaped by slow erosion over countless years. Deep, narrow valleys with steep walls show the work of glaciers that cut through the rock during times when ice covered much of the world. Mountains and valleys always change, even if humans cannot see it from one year to the next. With careful study, scientists can measure how fast a mountain loses height or how far a river moves its banks in a decade or a century. Today, instruments help people see changes as small as a few millimeters each year. Over 1 million years, these small changes add up to make entirely new landscapes. Sometimes, eruptions of volcanoes can cover a mountain with ash and fresh lava, adding new layers on top of the old landscape. When this happens, the slow work of erosion begins again, shaping the new surface as wind, water, and ice take it apart piece by piece. Living things are also part of how mountains change. Tree roots grow into cracks in the rocks and help break them apart. Plants hold soil together, slowing down some erosion, but when trees are removed, the soil can wash away much faster. Animals can dig into the ground, moving dirt and planting seeds that help hold the land together. Some mountain areas have lakes that collect water from melting snow and rain. These lakes can fill up with mud, sand, and small stones, becoming smaller over time as more material is washed into them. In very cold places, lakes formed by glaciers may eventually fill with soil as thousands of years of erosion add more and more dirt. Even the very highest mountain peaks do not last forever. There are places on Earth where tall, famous mountains once stood. Today, only rounded hills or wide plains remain, as millions of years of wind, rain, and rivers have carried away the rocks and soil. The material removed from the mountains ends up in new places where it can become part of new land, beaches, or even the bottom of the ocean. Sometimes when mountain ranges are worn low, other forces can push them up again. This is called uplift. As the heavy loads of rock are carried away by rivers and wind, the land underneath can rise. It is almost like mountains can have new lives, rising for a second or even a third time over millions of years. The process never stops. The land is always moving, just very slowly. Earthquakes and volcanoes are also part of mountain changes. When the ground shakes, large pieces of rock can fall or crack open. Volcanic eruptions put new ash and rock on top of old surfaces, while landslides and mud flows can quickly change the shape of a mountain slope. The climate is very important for erosion. Where the air is wet and it rains often, erosion happens more quickly. In very dry places, wind does most of the work. In cold places, glaciers are the main source of change. The amount of rain, snow, wind, and sun all decide how quickly mountains are shaped and worn away. The highest mountains on the planet are still affected by erosion. Even in the Himalayas, which are rising as plates push together, the wind and water take away some rock every year. In the Andes, huge glaciers have cut deep valleys over and over. In the Alps of Europe, ice has carved sharp ridges and deep lakes. In North America, the Rocky Mountains show both new peaks and old rounded hills worn by millions of years of erosion. People have used the materials found in mountains for a very long time. Rocks carried down by rivers can become sand for building. Soil washed from the hills feeds farms on the plains. Sometimes heavy rain can move huge amounts of soil and rock all at once, changing the paths of rivers or filling whole valleys. Sediments that wash down from the mountains are often carried to the sea. Here, over thousands or millions of years, they can pile up in thick layers at the bottom of the ocean. Sometimes these new rocks are pushed up again to form new land or even new mountains. The cycle of erosion, movement, and uplift is always making and remaking the planet. As mountains are shaped and worn by nature, they affect everything around them. The rivers and streams that begin as snow on the peaks become water for people, animals, and plants far away. The soil carried downhill feeds forests and fields. Valleys fill with rich earth, serving as homes for all kinds of life. Erosion, while it changes the land, also brings new resources and habitats for living things. Satellite pictures taken from high above the Earth can show how fast these changes are happening. Scientists use these pictures to watch glaciers, measure how fast rocks are breaking down, and see where rivers are cutting new paths. This helps people understand how fast the land is changing and where there might be problems, such as landslides or floods. Sometimes humans can cause more erosion than would happen naturally. When forests are cut or when roads and buildings are made on steep slopes, soil is left bare and washes away quickly. This can lead to problems like flooding, less water for farms, and loss of places where animals and plants live. Careful planning and replanting of trees can help slow down this kind of erosion. Mountains are always growing, wearing down, and changing. Even if a mountain has stood for millions of years, the forces of rain, wind, snow, and rivers are always at work. Erosion never stops, and neither does the slow, steady rise of some mountains as plates keep pushing from below. The balance between these forces makes the world's landscapes beautiful and always new. Erosion makes sure that no shape on the land is ever truly permanent. Rivers carve deeper valleys, glaciers create wide, flat basins, and wind smooths even the highest peaks. Over time, new mountains will appear as old ones disappear, and the face of the earth will always be different. Every rock, every valley, and every piece of sand on the plain may have once been part of a high mountain. The land is never lost. It is only changed and moved from one place to another by the patient work of nature. In this way, even as mountains wear down, the story of the planet continues from generation to generation, shaping the world for everyone who lives here. As the land keeps changing, there are times when the ground can move suddenly and in ways that people feel right away. The same deep forces that build and wear down mountains are also responsible for powerful events at the surface, such as earthquakes and volcanic eruptions. These natural events are all caused by the movement of the tectonic plates far below the surface. Without the slow and steady movement of these plates, there would be no earthquakes or volcanoes, and the world would be a much quieter place. Around the planet, tectonic plates meet at many different places. These boundaries between plates are often where the most dramatic events happen. Sometimes, two plates push against each other, sometimes they pull apart, and sometimes they slide past each other. Each kind of movement makes a different change to the land, and sometimes causes the ground to shake or break open. Earthquakes begin far under the ground, usually at the edges where plates meet. As two plates push or slide against each other, they do not always move smoothly. Often they get stuck together. When this happens, the rocks are squeezed tighter and tighter as the plates keep trying to move. All this squeezing and pushing creates energy. When the rocks cannot hold any more energy, they suddenly snap or slip past each other. This energy moves out in waves through the ground. When these waves reach the surface, people feel the shaking that is called an earthquake. Some earthquakes are small and people may not even notice them. Others are very strong. Buildings, roads, and bridges can break. Hillsides may slide down, water pipes may burst, and sometimes the ground itself can crack open. Earthquakes do not last long. Most are over in a matter of seconds or a few minutes, but their effects can change the land in a single moment. There are regions of the world where earthquakes are very common. These places are usually found along the lines where tectonic plates meet. In Asia, South America, and North America, there are long mountain ranges and deep trenches near plate boundaries. Cities built in these places, such as those in Japan, Chile, Turkey, and California, often feel earthquakes every year. Some are small, but sometimes a very large earthquake happens and can cause much damage to people, homes, and roads. Earthquakes can also cause other events. If an earthquake happens under the ocean, it can push up or pull down the water above it. This can create a huge wave called a tsunami. Tsunamis move fast and can travel across entire oceans. When they reach land, they can flood beaches and towns, washing away everything in their path. Mountains can be affected by earthquakes too. Sometimes a strong earthquake shakes loose rocks on a steep slope. These rocks fall, leading to landslides or avalanches. Whole sections of a mountain may change position slightly, and in some cases, new cracks, called faults, become visible at the surface. These sudden changes are evidence of how much energy is stored in and released by plate tectonics. Volcanoes also come from the movement of the plates. In some places, where one plate slides under another, the plate that goes down melts as it is pushed deep into the earth. When this happens, material rises back toward the surface as hot, melted rock called magma. The magma gathers in special places called magma chambers. As pressure builds up, some of this magma finds its way through cracks in the Earth's surface. When it finally escapes, it erupts through a volcano. There are many kinds of volcanic eruptions. Sometimes a volcano releases only ash and steam. Other times, it sends out thick flows of lava that move down its sides. Some eruptions happen quietly and the lava flows slowly. Others happen with great force and explode pieces of rock high into the air. Ash from volcanoes can drift in the sky for many kilometers and sometimes darken the sky. Volcanic ash and lava change the shape of the land. They can build new peaks, add layers to old mountains, or in some cases fill valleys and cover forests. Some volcanoes erupt often, while others may stay quiet for hundreds or even thousands of years. But even a quiet volcano can become active again if the conditions below the ground change. This makes living near volcanoes both exciting and risky. The soil near volcanoes is often very good for plants, but the risk of eruptions means that people must always be ready. The most active places for both earthquakes and volcanoes are along the boundaries of the plates. The Pacific Ocean is surrounded by a long belt where many earthquakes and volcanoes happen. This area is called the Ring of Fire. Other famous places are along the boundary between the Indian Plate and the Eurasian Plate, and along the edges of the African, North American, and South American plates. Plate tectonics is the driver for these powerful events. Every time plates move toward or away from each other, energy from within the Earth escapes in some way. Sometimes this energy moves the land up or down. At other times, it makes new mountain ranges or it opens new cracks in the ground. Some regions are known for very strong earthquakes, such as the west coast of the United States, Japan, and parts of New Zealand and Turkey. These places have systems in place to try to warn people and protect them from the worst effects. But it is never possible to know exactly when or where the next earthquake will happen. Volcanoes also have patterns that scientists watch closely. They use many tools to try to tell when a volcano might erupt. These tools measure shaking in the ground, small changes in temperature, and even changes in gas coming out of a volcano. If the signs look dangerous, people living nearby may have to leave their homes for safety. The ground does not need to move a lot to cause effects. Even small earthquakes or minor eruptions can change rivers, hills, and valleys. Sometimes hot springs or geysers form in areas where magma is close to the surface, bringing warm water or strange gases to the air above. The events caused by plate tectonics are not just destructive, they also help the Earth keep changing and renewing itself. After a volcanic eruption, the new rock cools and slowly becomes rich soil for plants. After an earthquake, new land forms and water may find new paths down the mountains and across the valleys. People have lived with earthquakes and volcanoes for thousands of years. Many old cities were built near plate boundaries because the land was good for farming or because of rich mineral deposits. Over time, people have learned many ways to prepare for these natural events. In some places, buildings are made stronger to stand up to shaking. In other places, plans are made to move people to safety if a volcano looks ready to erupt. Even today, with all the tools of modern science, the power of tectonic forces can still surprise people. Sudden changes remind everyone that the land is always alive, moving and shaping itself. Places that seem calm today may have been shaped by many earthquakes and eruptions long ago. Some of the most beautiful places on the planet are the result of these natural events. Lake-filled craters, jagged ridges, long valleys, and flat plains formed by old lava flows are all signs of volcanic and earthquake activity long in the past. When you travel or look at a map, it is easy to see how widespread these features are. The cycle of movement, eruption, and shaking has continued since the Earth first formed. Old mountains are worn away, and new mountains rise. Volcanoes bring new rock from inside the planet to the surface. Earthquakes move the land, sometimes only a little, sometimes in ways that everyone notices. This cycle connects all the different parts of the Earth. It is not just the land that is changed. The oceans are also affected by plate movement. When plates split apart mid-ocean, new seafloor is made, spreading the oceans wider. When they collide, deep trenches are formed. Earthquakes and tsunamis cross ocean basins, reaching distant coasts and affecting people and animals far from the original event. All of these changes are tied to the flow of heat and energy from deep inside the Earth. Even though the strongest events last a very short time, the energy they release has built and rebuilt the surface of the Earth over millions and millions of years. In some cases, new islands have formed from the sea when volcanoes erupt underwater. These islands may rise quickly and then disappear if the sea or the eruption changes them again. Coral reefs and plants find places to grow on new land, starting new cycles of life in the oceans. Volcanoes do not only erupt on land. Many of the world's volcanoes are under the sea. These underwater eruptions can make whole islands grow long ridges or even change ocean currents by adding new land to the sea floor. After earthquakes or volcanic eruptions, people sometimes find changes in the life around them. New streams may appear, old ones may dry up, and the soil may become richer or poorer for plants. The animal life may change as well, as some species move into the new environments created by the events. Scientists study the history buried under rocks and ash to understand how often big events have happened. By looking at old earthquake faults or layers of ash in the ground, they can learn about how the land changed in the past. This helps people know more about what might happen in the future. In mountain ranges, earthquakes and volcanoes can join together. A strong earthquake may shake loose rocks that have become weak from volcanic heat. Or a volcano can erupt because an earthquake cracked the rocks above a magma chamber. In these cases, the two forces work together to change the land. Many valleys and hills near volcanoes are made of layers of old ash and lava. Each time a volcano erupts, it adds a new layer. Each time an earthquake shakes the land, new cracks, faults, and landslides may be made. Over thousands and millions of years, these layers build up, making the ground very complex. Plate tectonics does not only make the surface dangerous, it is also the process that brings new minerals and resources closer to where people can use them. Metals, stones, and chemicals move from deep underground to the surface as the plates push, pull, and slide. Tectonic events also shape the climate by building and wearing down mountains. High mountains can block wet winds, changing where rain and snow fall. They also change the direction of rivers and lakes. Eruptions can even change the air for a short while if a lot of ash and gas are released at once. Earthquakes and volcanoes are signs that the inside of the earth cannot be held still. They show that energy is always building up and must find a way out. Watching these events helps people understand how active and living the ground beneath their feet really is. Throughout history, these powerful events have shaped where people live, the kind of houses they build, and the ways people prepare for danger. They have also given rise to stories, myths, and ancient histories about the world's mountains and volcanoes. Every earthquake and every eruption is part of a much bigger story. As the plates continue to move, the Earth's surface will keep changing. All living things, including people, must adapt to these changes. These natural events are reminders of the deep connection between the world's surface and what is happening far below, beneath the mountains, valleys, and plains. Events like earthquakes and volcanic eruptions show that the earth beneath us is always moving and changing. But the movements of the land do even more than shape the ground or cause sudden events. The shape of the land, especially the mountains, also changes the world's weather, the water cycle, and the way living things survive. Mountains are not only important for their beauty or their size, they change the wind, they catch rain and snow, and they help create many of the rivers on Earth. The way they rise high above the plains and valleys below has a deep effect on the whole planet. When moist air travels across the land, it sometimes moves toward tall mountain ranges. Air can move over flat land very easily, but when it meets a mountain, it cannot go through the rock. The air is forced upward. As it rises, the air becomes colder. When air cools, the water that is held inside it turns into tiny droplets. These droplets come together to form clouds. When the droplets in the clouds become heavy, they fall to the ground as rain or snow. This is why the side of a mountain that faces the wind usually gets more rain and snow than other places nearby. The air after passing over the top of the mountain has lost some of its water. As it goes down the other side, the air gets warmer. Warmer air can hold more water, so there is less rain on this side of the mountain. The land in this area is often dry and sometimes even looks like a desert. This difference means that one side of a mountain can be green and full of plants, while the other side can be brown or have less life. The rain and snow that fall on mountains do not stay there forever. Some of the water runs down the slopes and collects in small streams. Many of these streams join together to become rivers. These rivers travel great distances, carrying fresh water to valleys, lowlands, and even to the sea. In many countries around the world, the biggest rivers come from rain and melted snow on the mountains. Snow is very important to mountains and the land below them. In cold times of the year, snow builds up on high peaks and stays there for months. When the air warms up, the snow begins to melt. The water from the melting snow travels down to become part of streams and rivers. Even during times when it does not rain much, rivers can keep flowing because of the melting snow. This is one way that mountains help people, animals, and plants survive during dry seasons. Some mountains are so high that they keep snow and ice all year long. On these mountains, the snow never fully melts, and thick layers of ice are formed. These are called glaciers. Glaciers move slowly down the mountainsides. When large pieces of ice break off, they melt and add even more water to rivers and lakes. The water that flows from mountains is often fresh and clean. This water is important for many reasons. People use it for drinking, for farming, and for making electricity. Towns and cities in many parts of the world depend on water that begins as snow or rain on mountains. Sometimes, special lakes called reservoirs are made by building dams across rivers that come from the mountains. These reservoirs store water for times when less rain falls or more people need it. Because mountains rise high above the land, they also change the way wind moves. The mountain peaks and ridges can block or guide winds. Wind brings changes in weather and can carry rain clouds or dry air into different regions. The shape and position of each mountain range decides where rain falls, where snow is likely to come, and even where storms can form or stop. Sometimes, two nearby valleys separated by a mountain may have very different kinds of weather. One valley may be rainy and have thick forests, while only a few kilometers away, the next valley is dry and covered in short grass or even sand. Farmers, gardeners, and people who travel in these areas learn how important the mountains are for weather patterns and water supplies. Mountains also play a part in making special winds. When air moves down the sides of a mountain very quickly, it can become warm and dry. These strong winds can change the weather in minutes. Sometimes they bring sudden warmth to cold places. In winter, these dry winds can melt snow very fast. The weather on a mountain changes with height. The higher you go, the colder and windier it becomes. That is why the tops of tall mountains are often covered with snow or ice, even in the warmer months. The lower slopes may have forests or grass, while the highest peaks have very few plants. The temperature can change by several degrees from the bottom to the top. The way mountains catch clouds and make rain, snow, and rivers helps many kinds of life. Forests and grasslands grow on mountain slopes because the rainfall there can be high. Animals, large and small, come to mountains for water, food, shelter, and a safe place during bad weather. Rivers from mountains do not only help nearby places. Many rivers that start as small streams high up will travel hundreds or even thousands of kilometers. They bring water to distant valleys and plains. In many countries, cities, farms, and factories all depend on the rivers that come from mountain snow and rain. Rivers also move soil and small stones from the mountains to flat land. When the rivers are fast and strong, they carry larger rocks. When the river slows down, it drops the materials, making wide, flat plains, new land near river mouths, and even islands. These new soils make good places for farming. Sometimes floods can happen if there is too much rain or if snow melts too quickly on the mountains. The water can fill rivers faster than usual, making the rivers rise over their banks. Floods can change the shape of the land, and sometimes they can help by leaving rich soil behind. Mountains also help stop floods. The soil and plants on a mountain act like a sponge, soaking up rain and snow and letting the water move downhill slowly. Forests on the mountains are very important because they hold the soil together and keep it from washing away too quickly. Because the ground is often steep and rocky, water moves faster down a mountain than on flat land. Fast streams and rivers can carve deep channels, making canyons, waterfalls, and other beautiful shapes. The power of water is strong in these places, and it helps shape the land for many years. Many of the world's lakes are also made by mountains. Sometimes a glacier or landslide creates a deep hole or blocks a river, making the water collect behind it. Other times, the ground folds or cracks in a way that leaves a low area that fills with water. Lakes in mountain valleys can be deep, clear, and very cold, and they serve as important sources of water for people and wildlife. The rain and snow that fall in mountains can help clean the air and the ground. The water that runs off the slopes often carries away dust, pollen, and even pollution. Plants and animals living on mountain slopes have clean, fresh water to drink and use. Mountains also affect the air far away from where they are. By blocking and changing winds, they decide where rain clouds can travel. In some cases, air traveling over a mountain drops much of its water as rain or snow, leaving little water for the land beyond. This is why large deserts are often found on the far side of mountain ranges, in places where the air comes down dry. Not only do mountains control the water on land, but they also help decide where rivers enter the oceans. Places where many rivers reach the sea can become important habitats for fish, birds, and other creatures. River mouths are rich places, full of new life, because they carry food and fresh water from far away. Mountains themselves are home to many types of plants and animals. The weather, the water, and the steep land make special conditions. Some plants and animals live only in certain mountain areas. As you go higher up a mountain, you may find different kinds of trees, flowers, insects, and birds. Some animals travel up and down the mountain as seasons change, finding cooler or warmer places as they need. The height of a mountain also determines how much oxygen is in the air. The higher you go, the thinner the air becomes. Some animals and people who live high in the mountains have special ways of breathing or getting the oxygen they need. Mountain weather can change quickly. One moment, the sun may shine, and the next, clouds, rain, or snow may appear. People who travel in the mountains learn to be careful and prepared because the weather can become dangerous without much warning. The strong effect of mountains on water, wind, and climate also means that when mountains are changed, it can affect everything around them. If forests are cut or plants are lost, floods and landslides can happen more easily. Fires can spread quickly on dry mountain slopes. Care for mountain forests and soil is very important for the health of whole regions. Mountains not only shape the earth, but also provide resources for many people. They are a source of water, clean air, and even electricity when water from fast rivers is used to make power. Mountains also attract visitors who come to hike, climb, ski, or enjoy their special beauty. When people build towns or farms on or near mountains, they change the balance of water, plants, and animals. By protecting forests, planting new trees, and avoiding pollution, it is possible to keep mountain lands healthy and keep water clean for animals and people below. Every mountain, no matter how high or low, has a role in shaping the world's water, weather, and life. The movement of the earth made them, and they keep giving back to the planet every day by catching rain and snow, giving rise to rivers, regulating the climate, and offering safe homes to many living things. The story of mountains is not only about the ground moving and changing, it is also about how mountains keep the earth alive, green, and full of fresh water. The power of these giant blocks of land continues to help life in many ways, from the highest snowy peaks to the wide plains and seas far below. This deep connection between mountains, weather, water, and the world's many living creatures never ends. Life in the mountains is shaped by a special world of weather, land, and water. Every mountain has its own challenges for living things. The air is cooler, the wind is stronger, and there is less oxygen as you go higher. Even so, mountains are home to many different kinds of plants, animals, and people. They all find unique ways to survive and thrive above the flat land. Plants in the mountains are different from those in low, warm places. On the lower slopes, forests often grow thick and tall. Trees like pines, firs, spruces, and oaks cover the ground. These trees are used to cooler air and heavy snow, and their needles or leaves can survive icy winds. Higher up, the forests stop growing because it is too cold or dry. Here, the land may be covered in short bushes, small flowers, mosses, and grass. The highest places where trees cannot grow are called the alpine zone. Here, the ground is rocky and the soil is thin. Only the toughest plants can live. Some grow close to the ground to escape the wind. Many have strong roots to keep from being blown away. Their leaves may be small, thick, or covered in tiny hairs to hold in water and heat. These plants bloom quickly when the snow melts, making the high mountains dazzling with color for a short part of the year. Mountain animals need special skills and bodies to survive. Some have thick fur or feathers to keep warm. Others have extra-large lungs or special blood to get enough oxygen from the thin air. Goats, sheep, and deer can climb steep cliffs to find grass to eat and stay safe from hunters. Bears and wolves may roam the forests below for food. Small animals like marmots, rabbits, or pikas dig deep burrows to find shelter from cold and snow. Birds in the mountains often have strong wings for fast flying and sharp eyes to find food from far away. Some of the world's rarest animals live in mountain regions. The snow leopard, for example, lives in high Asian mountains where few people go. Small birds like the alpine accentor and animals like the ibex move up and down the slopes as the seasons change, always searching for food and the right weather. Mountain rivers and lakes are home to fish and frogs that can live in colder, clearer water than in the valleys. As the seasons change, life in the mountains also changes. Winter in the high places is long and very cold. Deep snow covers the ground and food becomes hard to find. Some animals hibernate, sleeping through the cold months. Others, like deer and birds, move down to lower, warmer slopes. In spring, when the snow melts, plants shoot up quickly and animals come back to feed and raise their young. Summer is short and can bring storms and bright sunshine on the same day. People have lived in mountain areas for thousands of years. Living on steep land is not easy. There is less air to breathe and the ground can be hard to farm. But people have learned many ways to use what the mountains give. They build homes with thick walls and roofs to keep warm in winter. In some regions, houses are made from stone, wood, or mud. The streets of mountain towns are often narrow and winding to follow the shape of the land. People grow crops in the valleys or on mountain terraces, flat steps cut into the slope to hold fields and water. These terraces let crops like potatoes, corn, barley, and rice grow in places too steep for normal farming. Animals such as sheep, goats, cows, and yaks are raised for milk, meat, and wool. The animals help people by grazing the rough grass that grows on the high meadows. Water from the mountains is the gift that mountain people depend on. Melting snow and rain fill streams and rivers, giving fresh water to homes, farms, and cities below. People use mountain water for drinking, watering crops, and even to make electricity by turning water wheels or running turbines in dams. Mountain people are often excellent builders. They make bridges to cross rivers, stone walls, and strong houses to protect themselves from wind, rain, snow, and landslides. Paths and trails wind up and down the slopes, connecting villages and bringing people together, even when cars or trucks cannot travel the steep roads. Donkeys, horses, yaks, and other animals are often used to carry goods and help with farm work. Villages and towns in mountains are sometimes far from big cities, which means that life can be quiet and simple. Mountain people share work with neighbors, help each other during storms or after landslides, and celebrate special days together. Music, dance, art, and stories are important parts of life, and many mountain communities have traditions that go back hundreds or even thousands of years. Some mountain areas are very high, where only a few people live. Others have busy cities with markets, schools, and hospitals. Tourists might come to hike, climb, or see the beautiful views. Visitors bring money and new ideas, but also need to respect the land and people who live there. Living in mountains can be dangerous. Earthquakes, volcanic eruptions, avalanches, and landslides can happen. Heavy snow can block roads or cover houses. Fast rivers may flood after heavy rain. People learn to be ready for emergencies and to rebuild when loss happens. Mountain weather can change quickly, making travel hard or risky. Sometimes thick fog or sudden snow can make it easy to get lost. Shepherds, hunters, and guides know the land very well and teach others how to stay safe. Many mountain people protect the forests and animals around them. Cutting too many trees can cause landslides or floods. If too many animals graze, the grass does not grow back. So, villages decide together how much they can take from the land and how to let forests and meadows grow strong for the future. Mountains are places of special meaning. For many people, mountains are holy or part of old stories about gods, spirits, and heroes. Festivals, prayers, and songs are used to show respect and thanks for the land. Some people climb mountains as a way of showing courage, asking for luck, or seeking peace. Food in the mountains often comes from what grows or lives nearby. Vegetables, grains, fruit, herbs, milk, and meat are basic in many mountain diets. People make cheese, butter, dried fruit, and cured meat to keep food good for winter. Wild plants, mushrooms, and berries are picked in the forests and meadows. Some families have small gardens or keep bees for honey. Clothes in the mountains help keep people warm and dry. Wool, leather, fur, and thick weaves protect against wind and snow. Bright colors or patterns in clothes can be seen from far away and sometimes show which village or group a person belongs to. Children help with animals and farming, learning from their parents and grandparents how to live in the high land. Mountain life is full of hard work. Every season brings different jobs to do: planting and picking crops, cutting wood, mending roofs and walls, herding animals, and gathering water. People celebrate the end of harvest, the return of the sun, or the melting of winter with feasts, music, and dances. Animals, too, are part of mountain life. Dogs herd sheep, guard homes, and help hunt. Horses and donkeys pull carts or carry people and goods. Cats keep grain stores safe from mice. Birds, insects, and wild animals are watched with respect since they all share the land. Art and stories come from mountain life. Songs are sung to welcome the morning or remember the past. Carved wooden doorways, painted cloth, and woven baskets show the skill and care of mountain people. Stories teach about bravery, kindness, and respect for the land. Children grow strong by playing outside, breathing clean air, and helping with family work. They learn the skills passed down through many generations. School in some mountains means walking many kilometers each day, sometimes across rivers or through snow. Some children leave for cities to study, while others stay to help with family farms. Some mountain regions are famous for minerals, gemstones, or special plants. People may mine for gold, silver, or salt, using careful methods to keep the land safe. Herbs and medicines are picked from high meadows, dried and sold in nearby towns. These resources provide work and help pay for other goods and needs. Tourism has become important in many mountain areas. Visitors come to see wild forests, high peaks, and clear lakes. Some stay in small family-run inns or go camping. The money they spend is used to buy food, care for animals, repair roads, and pay for schools and doctors. It is important to balance tourists' needs with the health of the land and the life of local people. Language and culture in mountain areas are diverse. Two villages just a few kilometers apart may speak different languages or have different traditions. Many mountain people know how to speak 2 or more languages, so they can trade and share with neighbors. As the world changes, mountain life also changes. Roads, phones, and new ways of farming or building connect remote places to cities. New machines can help with work, but can also bring new problems, like pollution or threats to ancient traditions. Young people sometimes leave the mountains looking for new chances, but many return to keep old ways alive. Protecting mountains is important for everyone, not only for those who live there. Mountains give fresh water, good air, wood, food, and plants for medicine. They are the home to many kinds of birds and animals. Keeping the land healthy means caring for the whole world. Many groups and leaders from around the world now work together to protect and support mountain lands. In every mountain area, the future depends on learning from the past, using the land with care, and sharing between people, animals, and nature. The story of mountains is the story of strong, patient life, always changing, but always full of hope. The people, plants, and animals that make home among the high rocks and snowy slopes show that, with respect and knowledge, life can flourish almost anywhere on Earth. The story of mountains is also the story of change. Every moment, small or large, the ground under our feet is shifting. In the highest places where people live, forests grow, and animals find shelter, the earth is always being made new. Some changes come slowly, taking millions of years. Others happen in a single day, as when an earthquake strikes or a volcano erupts. These ongoing changes are part of the natural life of our planet, and they show how mountains remain important for everyone. Mountains are always moving, but the movement is usually too slow for anyone to see. This is because tectonic plates underneath the planet are very large and heavy. They slide, press, or pull apart, moving only a few centimeters each year. These tiny steps add up to huge journeys given enough time. Mountains can rise as plates push together. They can also sink or change shape as plates pull apart or as the land slides down due to erosion. The rise and fall of the planet's surface never actually stops. When a mountain is first formed, it can be sharp and tall. Plates may still be moving under it, slowly pressing from below or from the side. When this happens, the mountain grows higher every year, even if only by a small amount. The Himalayas in Asia are one of the clearest examples. There, the Indian and Eurasian plates push together and the mountains still rise little by little. In other places, mountains rise less, or the force pushing them slows down. In time, erosion becomes stronger than uplift, and the mountain becomes worn down, losing its sharp peaks. Erosion is caused by wind, rain, snow, ice, and the movement of rivers. These forces break rocks apart and carry pieces of ground down the slopes to lower land. Over thousands or millions of years, large mountains can disappear, turning into rolling hills and wide plains. The pieces of rock that were once at the top of a mountain may end up at the bottom of a river, the shore of a distant lake, or even as sand in the ocean. Mountains are not always lost forever. In some places, after the ground is eroded and the weight above is removed, the land lifts up again. This is called isostatic rebound, which is just a way of saying that the Earth's crust can float higher as weight comes off. In this way, old mountain roots sometimes rise up to become mountains once again. The Earth really does build, wear down, and rebuild its surface in never-ending cycles. Along with this quiet shifting, mountains can also be changed dramatically by earthquakes, landslides, and volcanoes. When an earthquake shakes the ground, whole hillsides may move, valleys can open, or lakes appear and disappear. A landslide can bring part of a mountain down into a valley in just a few minutes, changing the shape of the land for generations. Volcanic eruptions can build a new peak, add new soil, or destroy what has been standing for centuries. All these events fit together to create a living, moving world. Mountains are important for more than how they look or how high they stand. They are home to millions of people and many more plants and animals. They give water to rivers that run through valleys and cross continents to reach the sea. The snow and rain that fall on their peaks fill lakes and streams, providing fresh water for drinking, growing food, and making energy. In this way, even the tallest, coldest mountain is part of life for people far away. Because mountains are always changing, people who live on or near them watch the land very carefully. They learn from every landslide, every new crack in the ground, or each change in a river's path. The signs of change are important for staying safe, finding water, and growing crops. In many mountain cultures, people have stories and traditions that help them remember where land has changed and how to live with these shifts. Mountains support diversity. Each zone on a mountain, from the deep forests at the bottom to the meadows to the rocky peaks, is home to different plants and animals. Some life forms grow only in special places high above the clouds. Others move between the forests and higher slopes as seasons change. The different climates and soils on a single mountain create many kinds of habitat, making mountains very rich in living things. The climate around mountains depends on many details. If a mountain blocks moist air, it can make one side wet and the other side dry. This shapes how forests and farms grow, where animals find shelter, and even where cities and towns are built. Each change in the mountain, each new slope, each fallen rock, each burst of water affects life not just in the mountains, but often far downstream. Mountains are essential for water. Every year, snow and ice melt fills rivers. If there is less snow because of warmer weather, rivers downstream may dry up. If a glacier shrinks, a river can disappear. The health of mountain snow and ice matters for millions of people and animals, not just for those who live at high altitudes. Human activity has become part of mountain change as well. Cutting forests, digging mines, building roads, or even hiking in fragile places can speed up erosion. New crops, clearing land, and grazing animals also affect how soil and water move. People can help mountains remain healthy by replanting forests, using gentle farming methods, and protecting steep ground from heavy use. Dams and reservoirs are also ways people change mountain lands. Building a dam stops the natural flow of a river, which can keep water for homes and farms or create new lakes for recreation. However, building a dam can flood valleys, move people from their land, and affect how fish and plants grow along the river. Using mountain water wisely is key for everyone who lives in the lowlands. as well as those in the hills. Tourism has changed mountains in many places. People come to see snow, climb peaks, and walk in wild forests. This can bring money and jobs to remote villages and help people learn to protect the land. But if too many people come, or if roads and buildings are made without care, mountain plants and soils can be damaged, and life can become harder for those who live there. Government groups, scientists, and local people now work together to protect mountain regions. They make laws, create parks, or teach about the importance of mountain forests, rivers, and animals. By working together, it is possible to protect the natural cycles that keep mountains rising, forests growing, and rivers flowing. All the steps that make and change mountains are part of a larger process called the rock cycle. Rocks are formed deep inside the earth, pushed up to make mountains, worn down by weather, moved by rivers, and then buried deep to become rock again. This cycle takes millions of years, but it never stops. Even the rocks you see outside your house may once have been at the top of a mountain or deep inside the earth. Mountains have a special meaning for people everywhere. They stand as signs of strength and endurance, but their real power comes from how they give life to so much of the planet. Without mountains, many rivers would not flow, forests would not grow, and food would be harder to find. The air and weather would change, and life would be very different. Every day, people living on mountains wake up to new changes. Sometimes it is just a stone rolling down a trail, or a new flower blooming where last year there was only snow. Sometimes a storm or earthquake brings big changes at once. All these things remind us that the world is not finished, but always growing, wearing down, and growing once more. It is the balance of these changes that keeps the land alive. Technology and science help us watch and understand these changes. Satellites take pictures from space to see how glaciers grow and shrink, or how valleys shift after rain. Seismographs listen for earthquakes. Weather stations high on mountain slopes record snow, wind, and temperature, helping farmers and towns plan for what is to come. Education and stories passed through families help keep people safe and teach the best ways to use the land. In every mountain town or village, knowledge about seasons, water, farming, and the wild is shared between old and young. Every lesson is important, carrying the wisdom of people who have lived with moving land for a long time. Mountain regions are places where people, animals, and the earth are very closely linked. What happens to one part of the mountain affects the rest. When the snow melts earlier in the year, plants may dry out and fires can happen. If too many trees are cut, floods or landslides can follow. Taking care of mountains means thinking about them as a whole system, respecting the ways they change and helping them stay strong for the future. The entire earth is shaped by these balances. The mountains teach us that small changes in one place can bring big changes somewhere else. Each river begins with a single drop of rain that fell on high ground. Each plain was once mountain rock carried down by slow, patient erosion. The world's most beautiful lakes, forests, and even deserts come in part from the rise and fall of mountains across time. Mountains give people what they need: clean water, wood, food, minerals, space to live, and places of beauty and rest. In return, people have the power to protect, heal, or harm these special places. Care, respect, and understanding let us share the mountains with all living things. Through every season, in every part of the world, mountains keep rising, rivers keep flowing, and life keeps changing. Whether you live near the mountains, visit them, or only see them from far away, they touch your life every day. Their story is not only about stone and soil, but about the wonderful connection of water, air, life, and all the living and non-living things of the planet working together. Even after millions of years, the same deep forces that built the first mountains are still at work. New peaks will rise, old ones will disappear, but the story of change, renewal, and life will always continue. Mountains show us not only where the land comes from, but how the world will always keep moving forward, always alive, always growing, always changing.